Okay, so today we're talking about writing the linear equation from graphs. All right. So yesterday we talked about linear equations. We talked about the y equals mx plus b form. So we're going to do the same thing here. We're going to write a y equals mx plus b equation, but we're going to take and try to write it from the graph. So our original equation, I'll write it up here at the top. Y is equal to mx plus b. Remember, in function notation, you could call that f of x if you wanted to, and that would be fine. So in this case, what we need to find in order to write this equation is we need a number for m and we need a number for b. And in this case, we use the definitions of what those things are. Remember that m is the slope. So m, the slope, is equal to the rise over the run. All right, remember the rise is the distance up or down, and the run is the distance left or right. Okay, so basically, if you want to get the slope from a line that's already plotted, what you need to do is pick 2 points on that line and find the rise and the run. All right, notice on this particular graph, the easiest way, and I did this on purpose because I didn't have graph paper, but the easiest way to find the points are points that hit right there on those particular numbers. So here's your first point, here's your second point. If you were on graph paper like this, remember it's sort of like this. Basically, you want to find places where that line hits the corner of the box. Okay, that's going to make your life easier because that's right at a certain number. All right, if you try to pick something between that, you're trying to estimate decimals and all that stuff, and you don't want to get into it. So you're trying to pick a place where it hits the corner of the box. In this case, in order to get from this point to this next point on the line, we have to go up 1. So our rise is 1, and we have to go to the right 1. So that's 1. Notice we went up and right, so both of them were positive. If we had to go left, it would be negative. If we had to go down, it would be negative. So your slope is 1 over 1, or 1. Now, remember, the b is the y-intercept, and that's where it crosses the y-axis. So this thing is crossing the y-axis at y equal to 1. So our b is equal to 1. So once we have the slope and the b, we can do what we did yesterday. We're going to lift out the m from this equation and put in the number that we found for m. So y is equal to 1x plus, now we lift out the b and put in the number that we got for b. So our equation is actually y is equal to x plus 1 because we don't have to write 1x if we don't want to. All right? Let me do another example here with you. In this case, we're doing the same exact thing. We first need to find m, which again is the rise over the run. In this case, if you're picking a point, notice this thing is flat. And remember, I said in class that flat slope is usually equal to 0. And if you want to prove that to yourself, you still pick 2 points. Pick 2 points. You have to go up 0, and you'd have to go over 1 to get to that. So 0 over 1 would be 0. So your slope is 0. All right? Your y-intercept, that's where it's crossing the y-axis. So this line is coming through and touching this up and down axis at y equal to 2. So your b is equal to 2. So now we've got m and b. We can plug it into our equation up here and get a number. So y is equal to 0x plus 2. But if you remember, 0 times anything is still 0. So we can say that this is the line y equal to 2. All right? And this is a special case of this linear form. This is a line that's going at y equal to 2. So as you can see, this line doesn't go up or down. It's always at y equal to 2. Okay? So you can have things like that. You can also have where x is equal to something. We'll talk about that later. All right? So let me flip it over. And I've got 2 more examples on the back. What I'd like you to do is to pause the video and see if you can figure these out on your own. Okay, take a second and do that, and then I'll be back with the answer to your problem. Okay, so the best place to pick a point is where it's hitting corners of boxes or right on a point. So here's my 2 points that I'd like to look between. I need to first find m, which is the rise over the run. So the distance up or down. So to go, say, from this point to this point, I have to go down 1. So we're going down, so that means negative 1. And then I have to go to the right, that's positive 1, 2, 3, 4. So my slope is negative 1/4. Okay? Now my b is where it crosses the y-axis. So it's crossing here at y equal to 1. So b is equal to 1. And then we're going to plug it into this general form, y equals mx plus b. I lift out the m and put in what I found for m, which was negative 1/4. So that's negative 1/4 x. Lift out the b and put in what I found for b, positive 1. So my equation is negative 1/4 x plus 1. In this one, if I want to pick 2 points, here's a good point. Here's a good point because they're touching. Touching right there at a whole number. All right. If I want to go from this point up to this point, I've got to go up 1, 2, 3, 4. So my slope here is I go up 4. And then I've got to go to the right 1, 2. So my run is 2. Now, if you can simplify that, you need to. So 4 divided by 2 is 2. M is equal to 2. Find B. B is where it's crossing the y-axis. It's crossing up here at y equal to 4. So B is equal to 4. So your equation for this line is y is equal to 2. Lift out the m, put in what we found, 2x. Lift out the b and put in the number we found for b, plus 4. And this is the equation for your line. If you have any questions, bring them to class.